our third edition of this AP Statistics 2020 exam review. This is our third of 13, remember, as we go through all the units and kind of prepare you as well as possible for this AP Statistics exam coming up on May 22nd. So what we're looking at right now is we're going to go through the second part of Unit 1. So if we, a couple things that I will show you and share with you, I have created I was able to go through, I have created an AP 2020 exam demo that I can share with you. The link is right there in the chat, and that is an AP 2020 exam demo. It's about 15 minutes long, and what it does is it shows you what it's going to look like on exam day from your computer. It also shows you how you can get to the formula sheet and to the to how you type in the calculator, and we'll talk about that a little bit later, and goes through and gives you some more information on what the questions will look like, and then your three options. And your three options, remember, for submitting are to copy and paste your response in, to upload a file, or to upload a picture of your response if you're handwriting it. So those are going to be your options that you have, and I've created a little video there that you can watch that shows the exam demo. So we're going to go through these 10 multiple choice questions and this one free response question. Let me share my screen with you so you see where we're at, and then I will move to the document camera. First of all, on the Stats Medic, we have completed the introduction, and hopefully a few more of you were able to get through the diagnostic test as well. But video 1.1 and video 1.2 we've done yesterday. We also went through 2015, the free response question number 1, and we went through how you would score that, how that one would be scored, and all the grading practices of that one. So today we're going to look at Unit 1 practice multiple choice problems. We're going to go through some of those together and see if you can help me as we answer those. And then we're going to look at the Unit 1 practice free response question. So we're going to look at those two. And at that point, we'll look at the solution and how the Unit 1 free response question is graded. And at that point, we'll kind of close out Unit 1. And that'll be all we're going to talk about on Unit 1 until exam day. So make sure if you have any questions or anything on Unit 1 that today is when you get that covered, and we talk about that today. All right, so let's go to, you have two options. You can follow along in two ways. If you were in my face-to-face class, I have printed off the multiple choice questions for you, so they are in your packet. If you're in online, if you click on Unit 1 practice multiple choice on the computer, the 10 questions will pop up. You can also download the PDF and print it off as well if you prefer to use paper pencil and kind of keep your notes there. All right, so I'm going to go to my screen, my presenter, and I'm going to start these 10 questions. So Unit 1 multiple choice. I'm going to read through the question, and then we'll talk about the response, and we'll kind of see where we're at. So question number 1, the graph below, question number 1, the graph below displays the amount of time to the nearest hour spent on homework per week for a sample of students. Which measures of center and variability, which is the same thing as spread, so which measures of center and spread would be most appropriate to describe the given distribution? Again, well, we can talk about it in chat. You can also unmute yourself as you go through this as well. So in this distribution, what is the shape of this distribution? Can anybody tell me the shape of the distribution?
Skewed right.
Yeah, that's what I think. Skewed right is the shape of the distribution. So it's not approximately symmetric, so it is skewed. So if it's skewed, what two measures, what measure of center and what measure of spread should you use in a skewed distribution? Yes, Mary. So the median and the IQR. Remember, if it is a approximately symmetric or approximately normal distribution, then we would want to use the mean and the standard deviation. Okay, so B is never going to be the answer. C is not either. E is not. So A is what we would use if it was approximately symmetric. And then D is what we use in a skewed distribution. And remember, the reason we would use the median and the IQR is because these are resistant to outliers. So if there are outliers, the interquartile range and the median are both going to be resistant to that. They're more resistant to it. The mean gets pulled with the outliers. The standard deviation gets pulled and made bigger with the outliers. The range definitely gets pulled with the outliers. So in a skewed distribution, you want to use the median and the IQR. All right, let's move to question number 2. Question number 2 says, the box plot below summarizes the heights in centimeters of a sample of 200 3-year-old males in the United States. Which of the following statements is false? So we want to know which one is false. So let's look at A. 50% of the children in the sample had heights between 93 and 98 centimeters. What do you think about A? Yeah, A is correct. So the box takes us from Q1 to Q3, right? So Q1 is the 25% mark. Q3 is the 75% mark. So there's 50% of them in that box. So A would be true. Let's look at B. 25 children had heights greater than 98. So 98 is Q3. So from Q3 to the maximum should be 25% of our data, right? 25% of our sample would be how many 3-year-olds? It would be 50. So this is going to be our false statement. So we really should have 50 children in this here. We should have 50 between Q3 and the median. We should have 50 between the median and Q1. And we should have 50 between Q1 and the minimum. So B, 25 children had heights greater than 98 centimeters. 25% of them were greater than 98. If we go through the rest, C, the 25th percentile is a height of 93 centimeters. Yes, that's Q1. D, the tallest child in the sample was 111 centimeters tall. Yes, that's the outlier right up here at the top. And then E, every child in the sample was at least 82 centimeters tall. Yes, the lower outlier is 82, so that's the lowest person in this sample. So we're able to show that the rest of them are true, and we're able to see that that one would be false, and then why. There would actually be 50 children because 25% of 200. Okay. So that gives us B for question number 2. So let's move on now to question number 3 at the bottom of the screen here. A college professor calculates the standard deviation of all the grades from the midterm exams she most recently administered. Which of the following is the best description of the standard deviation? So this is asking you basically for a definition. So what is standard deviation? I'll let you read through those for a second. Anybody have an idea which one they think would be correct and maybe why that would be correct? Xavier says D. Alexis says D. Yeah. So, yes. So the standard deviation, the definition of standard deviation is on average how far we are away from the mean. So the standard deviation takes into account all the individual grades and gives us the average distance from the mean. So A says the difference between the highest score on the midterm and the lowest score on the midterm. That would actually be your range. So obviously A is one that we can mark off really quickly. B says the difference between the score representing the 75th percentile and the score representing the 25th percentile. Well, that would be your IQR, right? Q3 minus Q1. So A would be your range. That's the definition of range. B is the definition of IQR. So we look at C. C and D are very similar, approximately the mean. So we go down to E, it says the median distance. Well, we're never looking at the median distance between these. So we mark off E. So we get down to C and D. C says the mean distance between each individual grade of the midterms exams. D says the mean distance between the individual grade of the midterm exams and the mean grade of all midterm exams. So the standard deviation is on average how far an individual score is from the mean. Yes, so that explains to you how far the individual score is from the mean, not from each other, but how far they are from the mean. That is your definition of standard deviation. All right. So the smaller your standard deviation, the closer all your scores are to the mean. And obviously, the larger your standard deviation, the more spread out they are and the farther they are from the mean in that. So does anybody have a question there on number 3? I think we went through that pretty thoroughly, and we'll move on to question number 4. All right. So question number 4 says, consider the STEM plot below, which gives the number of people attending a matinee show at the local movie theater for the past 26 days. So you've got 26 different numbers. And remember, it shows you in the key that 1/8 means 18. So this is 18. This would be 48. This would be 123 would be the biggest. So which of the following statements are true? So there are 3 statements here. First of all, the first statement says the 5-number summary is 18, 35, 54, 87, and 123. And the only way really that we're going to be able to prove that that statement is true is to go into our calculators and actually go into stat edit and enter this data. And that would probably be the easiest way. So as I look at that one, I'm going in my calculator and I'm entering 18, 20, 22, 25, and I'm going to enter these numbers, 30, and then I'll share my calculator screen with you, 33, 35, 37, 41, another 41, 42, 48. Then I have 53, 2 55s, a 58, 63, 71, 79, 81, 87, 92, another 92, 107, 111, and 123. Okay, so let me share my calculator screen with you. So I've typed in all the numbers into list 1, and if I want to find the 5-number summary, then I'm going to go ahead and go to stat calc, and I'm going to go to 1 variable stats. I'm going to use list 1 as my list, and I'm going to calculate. So if I scroll down, there's my 5-number summary. The minimum is 18. Q1 is 35. Excuse me. The median is 54. Q3, though, is 81, not 87. And the maximum is 123. So I make sure I type these in right. And I did. But so Q3 was different. Q3 was actually 81 instead of 87. So let's go to back to our screen. So that takes away statement number 1 because this part of the 5-number summary is actually 81. Okay, so let's look at the second one. Half of the data values are larger than 54. Is that true? So there's 26 data values here. Are half of them 54 would be right here? Are half of them more than 54? Yes. So there are 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You could just count that and see. You also can know that if 54 is the median, then half of the values must be below and half must be above. So that is true. So number 3, the shape of the distribution is skewed left. What is the shape of this distribution? Where is the tail? Is the tail towards the lower numbers or towards the bigger numbers? Where would be the tail of this distribution? Towards the higher numbers. So if you think about it on a number line, if the tail is, we can kind of make the curve here. If the tail is towards the higher numbers, then it is skewed on that number line to the right. So it really should be skewed to the right, which would take off number 3. So number 2 is the only one that is correct, and we circle B. Half of the data values are larger than 54. All right, let's go down to number 5. Which of the following statements is true? You want to look at this. Which of the following statements is true? Histograms have gaps between each bar. Is that true? No. Histograms all the bars have to be touching each other. Bar graphs have a gap between each bar. Histograms cannot have gaps between each bar. B, dot plots do not provide enough information to determine if there are outliers in the data. So is that true? Can you determine if there's an outlier from a dot plot? So this says dot plots do not provide enough information. Yeah, so that's not true because they actually do provide enough information. A dot plot gives you every single point in the distribution. So it is actually, so the dot plot is actually fine. It's going to give you every single point in the distribution. So a dot plot does provide enough information. So let's go to C. Bar graphs can display both quantitative and categorical data. What type of data does a bar graph display? Which one? Quantitative or categorical? Think about it now. Yeah, it's actually categorical because, so think about what's on the horizontal axis of a bar graph. You don't see numbers. That would be a histogram. you see categories, right? Like blue, green, red, whatever. We're talking about, so bar graphs actually only display categorical data, okay? And dot plots do provide enough information. Histograms do not have gaps between each bar. All right, so we're going to mark off C. D, stem plots are the best graphs for displaying data sets with two variables. Is that true? What's the best graph for displaying a data set with, if you have two variables, what type of graph would we use? Think about it. If you have two variables, if you have an X and a Y, what type of graph do we use if we have an X and a Y? Or what type of, like, what does it look like? It's not really a stem plot usually. With two variables, the best type of graph is usually a scatter plot. You see the X and the Y, and you can see the correlation between the two and how they're different and all those different things. So E is our answer, right? Box plots clearly show the 5-number summary of a data set. So you can clearly see the minimum, you can clearly see Q1, you can clearly see the median, Q3, and the maximum. So from a box plot, you're able to see all 5 of these things very, very easily. Okay, so that's question number 5. Let's move forward. Go to question number 6 at the top of the page here. And question number 6, the distribution has a shape that is strongly skewed left, which is most true, which is likely, so which is most likely true about this situation. So remember, the mean gets pulled in the direction that it is skewed. So the mean should be what compared to the median? What should the mean be compared to the median in this one? If the distribution is strongly skewed to the left. Think about it. So the distribution is skewed left. So I'm going to draw it for you guys. It means it looks like this, skewed left. So that means we have a lot of data here. So let's say a bunch of people got 90s and 100s on this test, and then a couple people got a 20 or a 10. Well, think about it. The median score would be over here in the middle, right, where all the most scores are, right, in the middle, 50th percentile. But the mean would get pulled down because of these low scores. So if something is skewed left, the mean gets pulled to the left. It's not resistant. If something is skewed right, the mean gets pulled to the right. If something is approximately symmetric, then the mean and median would be the same. So most likely the mean is getting pulled down to the left. So it is less than. So think in skewed left, the mean would be less than the median. In skewed right, the mean is going to be more than the median. And then if it is approximately symmetric, these are when they're approximately symmetric. That's when we expect the mean to equal the median or be very, very close to it. Okay. And skewed, if it's skewed in one direction, that typically tells you that there probably are outliers in the distribution. So E saying there are no outliers would be kind of an opposite thought there. Okay, number 7. Several students in an AP statistics class administer a survey to a sample of students in their school, asking the students how far they travel to school in miles. Which of the following Which of the following statistics would not be measured in miles? I want to ask you a question before we do this one. What is the variance? So what is the variance, though? The variance is what compared to, like, what is the variance? So a lot of times we don't even know what that is. We know the mean is the average. We know the median is the middle score. We know the interquartile range is Q3 minus Q1. We know the standard deviation is the average distance that we are away from the mean. But what's the variance? What is the variance compared to the standard deviation? Anybody remember that? The variance, what's the variance compared to the standard deviation? Yeah, it's the standard deviation squared. So the variance is the standard deviation squared. So the mean would be in miles, the median would be in miles, the interquartile range would be in miles, the standard deviation would be in miles, the variance would be in miles squared, okay? Because the variance is the standard deviation squared, okay? So the variance would be the only one that wouldn't necessarily be in miles. It would be in miles squared. Okay? So the variance is the standard deviation squared. I understand that's a pretty difficult one, right? But that is one that if you think about it, you can't see why the mean wouldn't be in miles. You can't see why the median wouldn't be interpreted in miles. It's hard to understand how the interquartile range wouldn't be interpreted in miles. The standard deviation is your average distance. That would be in miles. Variance, though, would be miles squared. All right, let's go to number 8. The following table shows how high school students in 4 grade levels ate their lunch on a particular day. They either purchased it in the cafeteria, they brought a bag lunch, or they purchased lunch off campus. What is the approximate proportion of juniors that purchased lunch off campus? So, only looking at juniors here. What is the approximate proportion of juniors that purchased lunch off campus? So first of all, how many juniors do we have in this table? 165, right. And how many purchased lunch off campus of those juniors? How many of those juniors went and purchased lunch off campus? 45. So we're going to say 45 out of 165. So we would go to our calculator and we're going to say, what is 45 divided by 165? And we get 0.27, okay? And that is D, 0.27. All right, that's question number 8. Let's move to the last 2 questions here for the multiple choice today. We've got question number 9. Question number 9 says, a club bowling team has 12 members. The first 10 members bowl a game, and their average score is 156. If you know the next 2 members bowl 173 and 151, do you have enough information to find the total of all 12 scores? So can you find the total? If you know 10 of them have an average score of 156, what's the total of those 10 players? If their average score is 156, what's their total? Yeah, 1,560. So the first 10 add up to 1,560. Then we're going to add 173, and then we're going to add 151. So we're going to say 1,560 plus 173 plus 151. And there we get a final answer of 1,884. So that is our total in question number 9. All right. So we didn't need to know the 10 individual scores because we knew their average. And if you know their average, then you know how all of them add up together. All right, number 10, the mosaic plot. So this is a mosaic plot. And a mosaic plot basically says, look, for students, this is their favorite math class. For students, 50% of them, their favorite math class was AP Stat. Okay, then it shows 30% of them from 50 to 80. So 30% of them, their favorite class was AP Calc. About 5% of them, their favorite class was Pre-Calc. And then about 15% of them, their favorite class was Intro Stats. Okay, for teachers, about 10% of them, their favorite class was AP Stats. About a little over, from 10 all the way to over 60. So a little over 50% of them, their favorite class was AP Calc. From 65 maybe to 95, about 30% of them, their favorite class was Pre-Calc. And then about 5% of them, their favorite class was Intro Stats. So if you've ever seen a mosaic plot like that, it's just basically, it's like a segmented bar graph is what you're thinking of. It's just showing you each of these different classes and giving you students and teachers and showing you what percent is true or what percent like each one. And it also goes all the way up to 100%, so you know you have everybody included in there. Okay, so the question is, based on this graph, which of the following statements is true? So based on that last graph, which of the following statements is true? We don't know anything about how many teachers and students there are at the high school. So E would be marked off. And why there would be more teachers than students, I have no idea. D says 80% of students chose AP Calc. We know it goes from 50 to 80. That doesn't mean 80% chose AP Calc. That means 30% chose AP Calc. So we know we can get rid of that one. A says there are more teachers than students who chose their favorite math class as AP Calc. Here's where you got to be careful. Teachers, about 55% of teachers chose AP Calc, and about 30% of students chose AP Calc. But if there's 1,000 students, 30% might be 300 students. And if there's only 100 teachers, 55% may only be 55 teachers, right? So we don't know that there are more teachers than students who chose their favorite math class as AP Calc. A lot of people go ahead and pick A. Now, there's a higher percentage of teachers. So teachers, a higher percentage of teachers chose AP Calc than the percentage of students that chose AP Calc. But that's not what answer A says. 100% of students chose Intro Stats as their favorite math class. That's kind of funny, but that means you didn't know how to read the graph. So the graph goes from 95 to 100. So that means only 5% chose Intro Stats as their favorite math class. So that leaves us with C. When combining students and teachers, AP Stats is the highest overall proportion. So it actually has 60%, a little bit over 60% who chose it as their favorite math class. AP Calc has just a little bit, if you look, AP Calc has the highest overall proportion who chose it. AP Calc actually has a bigger one. Now, but here's the issue. We're looking at the area of this. So this is where it gets really tricky with the mosaic plot. This is actually drawn to scale. So if you think about this, look at how many students and teachers. The black area is AP Stats. This is AP Calc. Now, take this part here and try to fill it in over here, and you would see that AP Stats, this huge area here, sorry, is actually larger than this area here for the AP Calc. I think that's one of the trickier ones, multiple choice, but it's going to show you the mosaic plot. So to find the category with the highest overall proportion, you want to combine the area of the rectangle for students with the area of the rectangle for teachers. And the biggest combined area is the AP Stat. Okay, so that is all our multiple choice questions for today. So let's move forward to Unit 1 practice free response questions. So if you're following along on, let me share with you, if you're following along online, then the practice free response question is right below practice multiple choice. So we click Unit 1 practice free response question. You can download and print off the PDF, or you can look at the question right here, and then I have these already printed. Okay, so Unit 1 practice free response question. Below are box plots that summarize the weights in pounds of large samples from 2 breeds of dog. We have the Anatolian Shepherd and the Black Russian Terrier. So there are the 2 breeds of dog, and there are their weights and the 5-number summary of each. It says, compare the distributions of weights for the 2 dog breeds. So first, we're going to write down the things that we would need. Shape, outliers, sitter, spread. Okay, first of all, shape cannot be determined from box plots. We talked about that yesterday. Outliers. Are there any outliers in these? Do you see any outliers marked for either box plot? No. So we would say both breeds of dog have no obvious outliers. Okay, so now we've talked about the outliers. Center, and you can't see this on your screen here, but if I take you to the computer, you can. The median, what would we say about the median for these 2 breeds of dog? What would we say about the median number? Yeah, they're very similar. Both breeds have a median right around 120 pounds. Okay, so both breeds have a median of right around or right at 120 pounds. That's where their median value is. So if you can't see that on your printout, you can mark it there as well. And lastly is the spread. Let's talk about the spread. First of all, what would be, so let's look at the, let's just do the 2 things. Let's say Anatolian Shepherd. What is the range of the Anatolian Shepherd? What is the range of the Anatolian Shepherd? What do you think its maximum is and what its minimum is? You can kind of guess, right? Just doesn't have to be exact. Would somebody give me that? Yeah, I think so. I agree, Mary. So 175 minus 100, so about 75. What is the IQR of the Anatolian Shepherd? So it looks like from here to about right there. What would we say that is? Maybe I'm gonna say maybe, let's say like 143 to 110. I think that's close at least. So about 33. Now let's look at the Black Russian Terrier. What is the range of the Black Russian Terrier? That's pretty easy to see. It goes from what? On the Black Russian Terrier, what's the range there? 155 minus 80. I agree. So that would be a range of 75 also. And then what would be its IQR? I would say from 130 to 105. So about 25. Now, we've got to compare these. We can't just write out what they are. So I'm going to continue part A down here, but I'm going to say the range for both breeds seems to be even at approximately 75 pounds. The IQR for the Shepherd is higher than the IQR for the Terrier by about 8 pounds. And we would say 33 minus 25. So now I've talked about both for the spread. Okay. Now remember, in describing or comparing a distribution, you have 4 parts. The first part is that the shape. But in the box plots, we can't do shape. So the next part is outliers. We talked about the outliers. The next part is the center. We talked about their center, which we had to use median because we have box plots. We then talked about their spread, the range and IQR. And we also got the context. Remember, it's stocks plus the context. Anytime we mentioned anything about the breeds or the pounds, we got the context of the problem as well. So we've completely finished part A. Let's look in part B. The sample of Black Russian Terriers does not contain any outliers. What weights would a Black Russian Terrier have to be considered an outlier? Okay, so they're wanting us to use the outlier formula. So for the Black Russian Terriers, 130 minus 105 is the IQR, right? So IQR is 25. We have to say 1.5 times the IQR. So we're going to say 1.5, and I'll move up just a little bit. We're going to say 1.5 times 25 is equal to, and we need to find what that is. That is 37.5. We're going to take that magic number, 37.5, and we're going to add it to Q3. And that's going to be our upper fence. So Q3 was 130. So 130 plus 37.5 equals 167.5. That's our upper fence. And then we would take that number and subtract it from Q1. So Q1 minus 37.5. Q1 is 105. So 105 minus 37.5 gives us 67.5. that is our lower fence. So now we've shown all our work, and basically now, since we've shown all our work, now we just have to write out our conclusion. So for a terrier to be considered an outlier, it must weigh less than 67.5 pounds or more than 167.5 pounds. And there is our conclusion. So, again, it tells us the sample of black Russian Terriers does not contain any outliers. So what weights would it have to be considered an outlier? So, again, we need to know the outlier formula. The outlier formula is you take 1.5 times the IQR. So the IQR was 25. 1.5 times the IQR was 37.5. Take that number and you add it to Q3 to get your highest that a number can be without being an outlier. And you take that number and subtract it from Q1 to get the lowest that you could be without being an outlier. So we know that the upper fence is 167.5. That's the highest you could possibly weigh without being an outlier. And 67.5 is our lower fence. That's the lowest you could possibly weigh without being an outlier. So does anybody have any question on that free response? So A, they were looking for, shape was not included. So they were looking for outliers based on the box plot. It should show you if there were outliers. Center, spread, and then context. They were looking for those 4 parts. So outliers, center, spread, context. And then in B, they were looking for 2 parts. They were looking for your work on the outlier formula, and all that work is down here. And then they were looking for your conclusion in the context of the problem. Do we have any questions on that free response and then how it would be graded? It's just put in the 2 parts right there. So in B, if you just did the work and got these 2 and didn't write the conclusion, you would only get half. You'd only get half of that right. You have to. And then also in A, you can't just write the range in IQR. You have to actually compare them. When it says compare the distributions, many times I've graded exams where they write shape, outlier, center, spread, and they put both of them, and they make a table with both, but they never compare them. They just write down, here's all the things that are true for the shepherds, here's all the things that are true for the terriers, but they never write an actual comparison. So when it says compare, you've actually got to use those words, like both of them have this, or one is higher than the other, or they are close or the same. So you've actually got to go and compare the 2. Okay? So that is your practice free response question for Unit 1. If I go back and share my screen, we have taken you all the way through Unit 1. We did our solution and talked about that. So I've taken you all the way through Unit 1, which is 1 variable data. So our next step when we come back here tomorrow, so on Friday and Monday, so our next 2 days are going to be spent on Unit 2, which is 2 variable, 2 variable data. Now, 2 variable data is going to be your X and Y, what you're talking about, your linear regression, basically, is what you're thinking of. So we're going to talk about describing a relationship, how to make predictions and residuals. So it's been a long time since you've looked at residuals probably as well. We're going to go through a free response question, and we're going to do that tomorrow. So we're going to do go through these 2 videos, take some notes on those, and go through free response question number 1. And then on Monday, we will do the Unit 2 practice multiple choice and look at another free response question from Unit 2. So that's where we're headed in the course. Again, we're going to spend 2 days on each unit, and that's going to take you all the way up to your exam on May 22nd for AP Statistics. So I thank you guys for being here today, and I appreciate your time and giving me your time and attention, and thanks for going through the stuff as well and answering the questions on that. That definitely helps that you're participating in the process, and I hope to see you back. Okay, so come back. If you know anybody else that needs to be here, bring them as well, and let's do great on this exam and make sure that we are going to get our college credit as well. All right, so have a good day. Enjoy yourself.